What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the exact values of these 6 trig functions, which I have conveniently written over here. And we're going to do all of this using the unit circle, all right? So we're going to go over how to find the angle, how to find the sine, cosine, tangent, cosecant, secant, and cotangents of different angles, all right? So first, let's start with an easy one. Let's start with the sine of pi over 6. So the first thing that we have to do here is simply locate pi over 6 on the unit circle. So you can see it's right here, right, where 30 degrees is. And then we just need to look at the coordinates, all right? So this is, of course, our x coordinate and our y coordinate. So whenever you want to find the sine of an angle, you simply look at the y coordinate. So in this case, the y coordinate is positive 1/2. So the sine of pi over 6 is simply equal to positive 1/2. All right, not too bad. Let's try a harder one now. So this one's going to be the sine of 13 pi over 4. So if we look at our unit circle, you might notice that there is no 13 pi over 4. So what we want to do in this case is actually convert this radian into degrees. And the way that we do that is just simply take your radian, so in this case 13 pi over 4, and then all you have to do is multiply it by 180 over pi. All right, so you might see that the pi on top and the bottom cancel out, which is great. And then on top, 13 times 180, we'll multiply those together and then divide by 4, and you'll get that this is equal to 585 degrees. All right. Now, obviously on the unit circle, this does not show 585 degrees, right? So this is our starting position on our unit circle, right? That's 0 degrees. And then to go all the way around, we know that's 360 degrees. Okay, so how much further do we have to get to 585? Well, we can simply do 585 minus 360, and that's equal to 225 degrees, all right? So we're gonna go all the way around, right? That's 360, and then we have to go another 225 degrees, all right? Well, we do have that on the unit circle, right? We have it right here, all right? So there's 225, okay? So you can see that 585 degrees and 225 degrees lie on the same line. And two different angles that lie at the same spot are called coterminal angles, all right? So what we basically found here is the sine of 13 pi over 4. Well, we again converted 13 pi over 4 to 585. So what we're actually looking for here is the sine of 585 degrees, which is the same thing as the sine of 225 degrees, all right? So now, again, in order to find the sine of an angle, we just need to look at the y coordinate, right? So the y coordinate here, as you can see, is negative root 2 over 2, all right? So we get negative root 2 over 2. Okay, now let's skip over to cosine. So now we want to find the cosine of pi over 6. So again, we just want to find our radian, which again, it's right here, same thing as 30 degrees. And this time, in order to find the cosine, we need to look at the x coordinate. So the x coordinate of pi over 6, as you can see, is positive root 3 over 2. All right, so here we get positive root 3 over 2. Now, if you need a way to remember how to correlate cosine with the x coordinate and correlate sine with the y coordinate, you can just think of a simple coordinate pair, all right? So a simple coordinate is simply x comma y, right? Our x coordinate and our y coordinate. Now, when you read these from left to right, they're in alphabetical order. So if I want to put cosine and sine in alphabetical order also, I'm going to put cosine first, right, C, and then we're going to put sine second, right, S. So as you can see, those are also in alphabetical order. So that's why I know that cosine correlates with x and sine correlates with y. Okay, now let's try a negative one. So now we have the cosine of negative pi over 3. So since we have a negative radian, that means, right, this is always where we start at 0 degrees. This time we're going to rotate in that direction, okay? But how much are we going to rotate? Well, if you look at just the positive direction for reference, pi over 3 is 60 degrees, okay? So instead of rotating 60 degrees in the positive direction, this time we're going to rotate 60 degrees in the negative direction. Okay, so again, this is our starting position, right? 0 degrees, or you could also think of it as 360 degrees. So if we start at 360 and then subtract 60, that's equal to 300, right? So then we get right here at 300 degrees. And again, we're looking for the cosine, so we want the x-coordinate. So our x-coordinate in this case is positive 1/2, right? So here this is equal to positive 1/2. Okay, great. Now let's move on to tangent. So this time we want to find the tangent of pi over 3. So pi over 3 is, again, right here, right, 60 degrees. And this time, in order to find the tangent of an angle, you set it equal to the y-coordinate over the x-coordinate. Okay, so we're going to set this equal to the y-coordinate, which in this case is positive root 3 over 2, right? Positive root 3 over 2. And then we're going to divide that by the x-coordinate, right? So the x-coordinate is positive 1/2. Now, in order to divide fractions, you can simply multiply by the reciprocal. So that just means take your top fraction, so root 3 over 2, and then you're going to multiply it by this bottom fraction, but just flip it. So instead of 1 over 2, we're going to have 2 over 1. All right, so then here you can see that the 2 on the bottom and the top cancel out. So then if we multiply straight across, we're going to get the square root of 3 over 1, which is equal to simply the square root of 3. All right, so that's the tangent of pi over 3, positive root 3. Okay, now let's move on to the last 3. So here we have the cosecant of pi over 3. And as you can see, cosecant, if I spell it out, cosecant, you can see it has a co in it, or it basically has a cosine in it, right? So you would think it correlates to cosine, this cosine, which is x, but it doesn't, okay? Because as you can see, to solve for cosecant, it's simply 1 over the y-coordinate, all right? So it's a little counterintuitive. Cosecant correlates with sine, and secant correlates with cosine. Now, in order to solve for cosecant, again, we're simply going to set it equal to 1 over the y-coordinate, right? So here we're going to say that this is equal to 1 over the y-coordinate of pi over 3, which in this case is root 3 over 2, right? So root 3 over 2. Now again, to divide by a fraction, we can simply multiply by the reciprocal. So here we'll just take what we have in the numerator, which is just a 1, and then we'll multiply it by this one, but we're going to flip it, right? So we're going to have 2 over root 3. So anything times 1 is just itself, right? So 1 times 2 over root 3 is equal to 2 over root 3. Now the problem here is that we have a square root, right, a radical in the denominator, which is not allowed because that makes this irrational. So to rationalize it, we simply have to multiply by this denominator on the bottom and on the top. Okay, so then on the top we have 2 times root 3, which is equal to simply 2 root 3. And on the bottom, the square root of 3 times the square root of 3 is equal to simply 3. All right, just a couple more here. So now we're going to find the secant of negative 5 pi over 4. So first of all, let's just find the positive where 5 pi over 4 is. All right, so positive 5 pi, 5 pi over 4, right here. All right, so positive 5 pi over 4, right? Start at 0, and then we came all the way around here. So that's a rotation of 225 degrees, right? But this time we're going in the negative direction. So we're going to head at negative 225 degrees, right? So we're going to, again, start at 0 right here, and then we're going to head back 225 degrees. So if you want to work that out, you could simply do 360 minus 225, and that's equal to 135 degrees. All right, so 135 degrees is right here. Okay, so we can simplify this. We can say the secant of, instead of negative 5 pi over 4, we could simply say 135 degrees, right? And again, to find secant, you simply set that equal to 1 over the x-coordinate. So this is going to be equal to 1 over the x-coordinate. The x-coordinate in this case, negative root 2 over 2, right? So we're going to divide this by negative root 2 over 2. Okay, and let's move this up right there. And again, in order to divide by a fraction, we can simply multiply by the reciprocal, right? So here we're going to have 1 times, and then it's still negative. So we're going to have negative 2 over root 2. Now again, I think times 1 is just itself. So this is going to be equal to negative 2 over the square root of 2. But again, we need to rationalize this denominator, and we'll do that by simply multiplying by the square root of 2 on the bottom and on the top. So this is going to be equal to, on top, 2 times root 2 is equal to just 2 root 2. And on the bottom, the square root of 2 times the square root of 2 is equal to just 2. And here we basically have a negative fraction times a positive fraction, which is equal to a negative fraction, right? So here we have a negative. Now, lastly, you can see we have a 2 on the top and the bottom, so those cancel out. So then this whole thing simply is equal to negative root 2. All right, lastly, let's go over cotangent. So this one definitely is paired up with tangent, all right? So tangent is just y over x. So cotangent is just the opposite, right? X over y. Okay, so first let's locate 2 pi over 3, which is right here. So the cotangent of 2 pi over 3 is going to be equal to, again, the x this time is going to go on top. So this time we have negative 1/2. And that's divided by the y-coordinate on the bottom, which is root 3 over 2. All right, so again, in order to divide these, we can multiply by the reciprocal. So this is going to be equal to negative 1/2 times 2 over root 3. All right, so then here you can see we have a 2 on the top and bottom, so those cancel out. And all we're left with is a 1 on top and root 3 on the bottom. But remember, it's negative, right? So negative 1 over root 3. So again, we have to rationalize this denominator, right? One last time, like so. All right, so then here, this is going to be equal to negative, and then on top, 1 times root 3 is equal to root 3. And on the bottom, root 3 times root 3 is equal to just 3. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.